So today's lesson is going to go over what is area and how do you find area. So who uses area first of all? Architects, carpenters, home decorators, engineers, tile layers, painters, and of course students. So these are just a few examples of who is going to encounter area and will be using it. Again, there are many more examples we can also add to this. So what is area, just in case we don't remember? So how is it different from perimeter? Remember, the perimeter is the distance around an area, so the length around the shape, I mean. Area is a little different. Area is the amount of surface enclosed by a figure or an object. So what's the space on the inside of an object, not the distance going around the object. It's space on the inside. So again, here are some just standard shapes that you would find the area in, especially at this level, like rectangles, triangles, again a trapezoid, and here we have a diamond shape, which we call a rhombus. So let's kind of move on and see how do we find the area of an object. So it pretty much comes down to is you measure the area by counting the number of square units that will fill in a figure completely. So what do I mean by square units? So if I were to chop up a piece into a whole bunch of little squares that measure 1 by 1, so we call it a square unit because each distance is 1 unit refers to 1, so the distance or the space is 1 square unit. We put the power of 2 on it because it's a square, so again it's called a square unit because each shape is an individual square. So let's say for example I have this grid and I draw a picture on it. So let's say for example, let me actually draw like a rectangle here. So if I wanted to find the area of this rectangle, I would just count how many individual 1 by 1 squares there are. So if I were to go ahead and chop it all up into individual squares, this rectangle would measure 6 square units because there are 6 squares within this rectangle. So moving on, this is where you're going to be taking notes on your paper. It's on the 3rd page of your handout. So again, the definition is right there for your convenience. Area measures the surface of something in square units, U squared. It can also be in inches squared, centimeters squared, yards squared, whatever unit you want to replace that for. Again, the area is the number of square units inside. Hold on, that was a mistake. The area of a figure is the number of square units needed to cover the surface. So again, looking at this other rectangle, again, you're not going to have all the little dots in between. You have to kind of imagine it being broken up into the correct number of squares. So in this case, if I go ahead and start breaking down this rectangle, it measures 5 across and 3 up and down. So I'm going to go ahead and break it apart into 5 in one direction, 3 in the other one. If I go ahead and count the individual squares, I can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this rectangle would measure 15 meters squared. Again, it's meters squared because the measurements are in meters. So again, remember each square is worth 1 meter square, so it's a total of 15 squares. So the area is 15 square units. So now we're going to talk about a shortcut to this. Instead of always breaking down a picture into squares and counting them, especially when the numbers get bigger, you'd not want to be counting 100 or 200 or 300 squares. So we have a general formula. The 15 can be quickly found by just, multiplying the numbers 5 and 3, because 5 times 3 is 15. So a quick formula for the area of a rectangle would just be multiplying the distance across and the distance up and down, which is just the length times the height, or the base times the height, or the length times the width. So we're just going to write that down on the formula line. So it's just the length times the width. Sorry, it's so sloppy. I'm sure you guys can write it a lot neater. So it's just length times width. And we're going to go ahead and do 3 examples at the bottom. So again, bottom of the page you have 3 examples. You guys will go ahead and write these out. So let's go ahead and move on to the next slide. So this is example number 1. Again, make sure you write big enough so you can actually fit this information and not get it all down in a bad way. So again, make sure you have enough room to write these out. So again, we have a rectangle here. Our formula is just the length times the width. So that's what we're going to be doing. We're going to be multiplying the length distance, which is 2x plus 6, times the height, which is x plus 3. Again, the side measures are not regular numbers. They are expressions. So we're going to have to multiply two polynomials here. So again, my area is going to be 2x plus 6. Again, sorry for the sloppiness. I don't have my correct writing utensil here. So we're going to do 2x plus 6 times x plus 3. Make sure you guys write that down. So this is a 2 by 2 polynomial, a binomial times a binomial. I'm going to use my box to multiply these. So I'm going to go ahead and draw my box to multiply these two. I'm going to set up the box. I'm going to have 2x on the side here and the 6. On top I'm going to have my x and my 3. So I'll give you guys a second to write that down and to start multiplying it out. And I'll start writing in the information now. So 2x times x here. So that's going to give me 2x squared. Let me go ahead and change the color. Let me see if I can figure this out. Actually, I can't right now, so I'll just go ahead and write it down. 2x squared. And 2x times 3, that will be 6x. Bottom we have 6x. 6 times x is 6x. And the last box is a 3 on the top, a 6 on the left. It's an 18. So I just finished multiplying. Now I'm just going to write out my expression. So highest power is 2x squared. I'm going to combine like terms. I'm going to combine the two 6x's here. That's going to give me 12x. And I'm going to finish it off. Actually, let me make that a little neater. It's a little messy. Start again. So plus, that's not quite so nice. Let's try it again. Plus 12x. And then the last term is just the 18. And that's my final answer for number 1. Give you guys a few seconds to finish copying it down. But again, just multiplying for the area of a rectangle is length times width, or base times height. It means the same thing. Doesn't matter which one goes first, which one goes second. Set up your box, multiply it out, combine like terms, and we have our final answer. 2x squared plus 12x plus 18. We're going to go ahead and move on to the next example. Alright, here's number 2. Now we're going to do the area of a rectangle. So the formula for the area of a rectangle is actually different. Here is the formula. Area is 1/2 base times height. I'm sure this looks familiar. If it doesn't, make sure we write it down. So let's go ahead and find the area of this triangle. So we're still the same thing as before. We're going to multiply the base times the height and then just divide it by 2 after we're done. So I'm going to go ahead and set that one up. So area is equal to 1/2 the base, which is 2x minus 6, and the height is x plus 3. Right, there's my setup. I'm going to go ahead and first multiply the two binomials. I'm going to draw my box, multiply it out, and then just divide the final answer by 2. It's just an extra step, dividing by 2. So I'm going to go ahead and start the box over here. I'll put 2x minus 6 and x plus 3. And just repeat the same process as before. It's very similar to the previous problem, same idea. We're going to go ahead and start multiplying. 2x squared, 6x, negative 6x. Don't forget about those negatives. And negative 6 times 3 is negative 18. That didn't come out like an 8. Let's fix that 8. Alright, Now I'm going to go ahead and write out my answer and combine like terms. Remember, I want to combine these two right here. So I'm going to have 1/2 still. These two get multiplied and get one answer. It's 2x squared. The 6x minus 6x cancels out, so that becomes a 0. So I don't write anything down. I'm going to put my minus 18 here. Now that I've multiplied the base times the height, now I'm going to do half of it. Remember, area of a triangle is half base times height, so I'm going to take half of each of the two terms. So if I take the 2x here and I divide it by 2, 2 divided by 2 is going to give me 1, or half of 2 is 1, so it's just going to be x squared. If you want to put that 1, that's fine. You don't have to put the 1. It's the same thing without it. Now I'm going to go ahead and multiply 1/2 times negative 18, or subtract 18. So again, half of 18 is 9, or 18 divided by 2 is 9. So I'm going to have minus 9 here. So my final answer here is x squared minus 19. So this is my area of the triangle, x squared minus 9. Give you guys a chance to finish writing it down if you haven't done so, and then we'll move on to the next example and the last example. All right, here we go to the next example. Last example is we have a rectangle again, but this time the 4 corners have been cut out from each corner. So a piece of x by x has been removed from each corner. We don't know what x measures. It can be 1 centimeter, 2 centimeters, and so on. But the entire rectangle with the pieces that were cut out would be a 24 by 18. So going back to what we know about the area of a rectangle, we know the area is, let me remove that one and put the regular pen. Area is equal to just the base times the height, or length times width. So the base is 24 inches, 24 centimeters, and the height is 18 centimeters. So we're just going to assume that the entire rectangle is 24 by 18. We'll take care of the cutout pieces later. So I'll just go ahead and fill those numbers in. 24 times 18. So again, you can go ahead and use a calculator to figure this out. 24 times 18. I'll give you guys a second to look it up on your own before I put up the answer. Alright, you guys should have gotten 432. Now, if this would be our final answer if these 4 corners were not removed from the rectangle. So now we have to remove 4 of these rectangles that measure x by x. So I'm going to go ahead and figure out the area of those little rectangles, or squares I should call them, that are on the side. And they each measure x times x. Remember, it's base times height. Base is x, height is x. X times x is x squared. And remember, we are removing 4 of these rectangles. So that means we're going to be subtracting 4 of these x squared. So there should be 4 of these being removed. So going back to our previous area, 432, we're going to subtract x squared from it 4 times. So my final answer is going to be 432 minus 4 of these x squared pieces that were subtracted or cut off the rectangle. So my final answer is 432 minus 4x squared. And we are finished.